See, if you see the satellite image, what you see is actually red in color because the vegetation has been given red. Okay, why that I will explain later. Okay, but you can only see here. See, for example, if you see here, you see we have the Western Ghats, we are somewhere here, and these are all the Eastern Ghats. Then we have Central India. This area is called the rain shadow region because of the hills which is there, and the rain shadow region. We have a lot of reservoirs which gives irrigation here. All this is dry area. Without this irrigation, channels of Krishna and Godavari. Then we have a dry desert, sandy. Then we have cold deserts and also alpine hills. And then we have Sundarban's delta, which is also unique. And we also have here different deltas of the river systems which start in the west but comes to the east. And then we also have the northeastern region where the relief length ratio is less. Relief length ratio means the water to accumulate will be shorter in time. So all these have come along with the continental shelf. On the western side, eastern side is different. Then we have the Lakshadweep Islands here, and we have the Andaman and Nicobar Islands. So we have islands, we have a peninsula, we have three seas are there, Arabian Sea, Bay of Bengal, and Indian Ocean in the south, and then your host of landscapes. No other country has such diversity. See, that is the uniqueness of a country. That means you can do any type of experimentation. And another one, we are mostly in tropical. Okay. So the things, instruments, whatever you do, can have certain biofouling. Biofouling means the instruments will not be the same because the life formation here is much faster. So they can grow certain fungus, etc. much more than the temperate climates where these instruments are made. That means the Europe, the Western world is more of temperate climate. So we should understand this. So any instrument you are trying to measure, we should be conscious about it and solve that. If you are solving here, whatever you are doing, it easily can be taken to any part of the world. So that is the advantage what we have here. Testing here is difficult, fabrication is difficult, but once you do it, even 80% you are successful here, you are 100% successful on the other side. That's the difference. Okay? So we don't have to be 100% successful here. But 80% you are achieving, you are 100%. You can close your eyes and then it will work there. See the other beauty what we have. We have water resources. This is broadly 400 million hectameters. This is the water which comes as precipitation. And this precipitation, of course, we have to add some 20 million hectameters in terms of the snowfall and all what we have. But whatever we are having, we are only using 51 approximately for irrigation and other uses. But where is this rainfall coming from? And how much of geographical area? Because we have some 329 million hectares, right? That's our area. Am I right or wrong? Okay. If I am wrong, please tell me, correct myself. So, and out of the 328 million hectares, how much is the area we are getting out of 750 mm rainfall is good rainfall? And large part of the country is getting a coverage. Because we already have certain deserts, right? That's why you have a lot of sandy deserts, we have cold deserts, etc. And then, but where is this rainfall coming from? 296%. 296 million hectameters, that's not almost 300, is coming in southwest monsoon. But the difficulty part here is, this has a variability of 74%. That means 74% we can get excess, we can get less. This is where we have to be prepared for when we talk about sustainable development. We have to understand these factors and plan accordingly. So how do you plan this? There are simple three principles of planning in terms of what we call as resources management. It can be applied for in our office, which can be applied in natural resources, whichever is there. So what are those three? One is preservation. That means no human interference at all. Conservation, use with caution. People tell us, no, save money, some money for tomorrow. Conserve. Because we need to have something. We cannot spend everything. With nature, we cannot take loans. We cannot take advances. Okay? Only today is possible with the economy which we are trying to get. So we cannot apply that in nature. The third is development. Development means only for human beings. There will be beneficial for human beings, no one else. These three if you keep, it is called management. So when how do you balance these three, it becomes the management. So if you are able to understand this and apply it to sustainable development, needs today and needs requirements of the future without endangering the ecology and environment. So definition is simple, right? So now we look into whether space technology can do something for us. Okay? Is it okay? Okay, I will tell next. So we can go next. Yeah. So this is all about. I'm not going to this. Why this is all what we have. We have a long coastline of 7,500 kilometers. In the image I explained to you everything. And we have a lot of rain for agriculture coast. We have also cattle. Almost 70% cattle of the world cattle is there with us. But these figures are different. Now we have around 305. Now we crossed. We intended 250. We supposed to be 325, but we are already 305. That means we are coming much faster than what was required. But is it sustainable or not? We have to question. Okay? It has given some yield. We used to give the yield. But the population which was 20. If the population we cross faster now. 2030, 1.43 million. But what are we now? Already crossing somewhere, right? So we are faster. Okay? So everywhere we are faster. Next step. Now these are the problems. What are the agricultural land we have? We have a lot of degradation is happening very fast. That means the topsoil is getting eroded. Okay, so we need to conserve that. Or else they are all coming to our ponds, tanks, irrigation dams. So the life of those water storage structures will be reduced. So we need to ensure that the catchments are properly treated so that erosion will not happen in the same pace. And the runoff, that means whatever precipitation rainfall is coming, it is moving slowly. What we are going to do? We are only going to impede the flow. We are reducing its speed. If you reduce its speed, it will not create any damage. If you let loose, it will go faster. Yeah. So these are all the things of a very simple nature which you need to get. So and also the country experiences what is called drought. Half of the country. Many a time this doesn't come under the newspapers, media at all, attention. Many a time there are things which vanish. Even the cattle also vanish. In fact, now it has been found our civilizations which are there in the Indus, maybe 3,500 years back, we had long droughts of almost like 90 years. That's how the entire civilization is gone. 90 years is a too long period to sustain. 1 or 2 years is okay. Some cattle lost. But then we can predict these things. Today we have the technologies to predict and also sustain these resources, how to go ahead and then work towards it. And I'm not going to details of it, just get a glimpse of we have certain problems which we need to address when we are doing that. And then, how do we do? We have to look a scientific way of, how do we scientific? So we have to understand what is the strengths or potential of a resource. It can be soil, it can be water, it can be vegetation. We have to understand its strength and its limitations also. Because all are not the same strength. There will be some limitations of each and every. Suppose there are fossil sands. They are nice to walk, but they are very loose. So if a tidal wave comes, they get eroded fast. So how do I strengthen that? Okay, that's how we look at it. So I'm telling you simple examples to understand what we're talking about. But more importantly, we need to have people's participation. Without people being part of it, there is no use of doing anything because we are a democratic society. Finally, whatever planning being done, it has to be acceptable to to the people who are living there. And sustainable development, no? So the people part of sustainable development. Correct? So that is where we need to understand that very clearly. And we need to do an integrated approach. Why integrated, I will explain a little later in a slide. Now, see this state. I was telling this is part of Western Ghats, where we came from Kerala, when you extend to the top. Because of the vegetation and the hill scar, you are seeing it red. And these are irrigation. But then this all bare soil is here. Because there is no, this is all rain shadow region. And this space is where mostly 70% variability of rainfall is always there even today. And here is our dry deciduous forest. That's where it's British red. That is all irrigation. So, if you see this part of the sea, now I will show you the next slide, located here, is a place called Satara. We also have a hill station, Mahabaleshwar. Okay, that's where you will see very closely. You see this is only 10,000 square kilometers this sea. Here you will get 3,600 mm of rainfall. How much? 3,600 mm of average rainfall. But in the same district, we have another taluka called Man. Here, this one. This gets only 400 mm rainfall. Very less. And hardly there are 10 rainy days. In Kerala, you have so many rainy days. No? So can you think in one district such kind of a variability? That is there in our country. So one district alone will be making all of them. So this is where this is an opportunity for you. You should not think there is a problem. But in such a variability is there, how do we keep thinking? How do we assess the resources which are available? How to interplay of this? This is an opportunity for you to think. Then we get to observation. Isn't it? Morning I told you some keywords. Okay, how do we observe? The next. So this is where we have the electromagnetic spectrum. This is what observations we do. Our natural light does and what we do. Whatever we cannot do, we use certain optics. We use some filters. Okay. I'm not going into very much details because you're all from different levels of education you're all coming from. So we try to understand only the basics of it. The details will go a little later. So whatever we cannot see with our natural eye, we are using some sensors, with optics and certain filters, only to look into some frequencies. Some frequencies of the wave. If you are using the sun's electromagnetic radiation, that's called passive type of remote sensing or observation. But if you are using our own energy, that means the satellite itself will send a frequency in which it will go and you will see how it is interacting with the objects and you collect the data, that is called active remote sensing. Okay? So that means we don't need sun there. In the night time also can operate. You are sending energy what it will. Night also you can do. That's why it is done in active in the radars. That's called all-weather capability. So we also have a radar image. But those radar images will not be the same type of images which you see in the visual part of the, whatever visually you see, it feels in a different color, that we don't get. We get some other inferences, please understand. There is a strength, but there is a limitation to understand. So here, there are some factors, what human eye sensitive to and how we do the model. So here, the larger the wavelength, more the penetration. The larger the wavelength, that's where radio is larger wavelength. So even we hear from somewhere, we can hear even from, you're in a room, you can hear that there is a approach you can do to certain extent. Whereas radars also, they have larger wavelength, so they can penetrate to the vegetation, they can penetrate to the soil, they can go to subsurface. Okay, so the larger the wavelength, more penetration. The shorter the wavelength, they can be scattering. If they are really scattering, we cannot see much. That's why in the blue region, in our atmosphere, there is a scattering. But in moon, on moon, we don't have atmosphere. So you can use all parts of the electromagnetic spectrum, right? Only on Earth you have this. So these are called windows of opportunity, windows of remote sensing. Yeah, next. So here, normally any image is in black and white. Okay, in that frequency we take a black and white grayscale image. And then we have multiple frequencies, so that is called multispectral. But then there is another concept called hyperspectral. That means continuously we can image same area. Okay, so for example, this is a hyperspectral image. many images are there? That means in one shot, it's taking in all the frequencies. When the satellite is there or the drone is there, in one location, within a few seconds, it is operating all the frequencies within the frequency band. It gives you so many images, maybe something more than 200 images. So then, humanly, it is possible for you to see all the images. It's not possible for us to see all the images. And so then what we do? Normally, most of the time we do is multispectral. But when we go to hyperspectral, we can differentiate simple things. Whether it's a tile roof, is a roof which has the soil sheet, or is it a thin, or is it a plantation of a tea plantation, or a pine plantation. Each one we can differentiate just as that the image. But to do that, we have to make a signature library. So these are the signatures. That means every feature in different part of the wavelength, how it will reflect as, these are reflectors. How they reflect, where it gets absorbed, these are reflectors. So we can make curves for each and every one. If you see the vegetation curve, the vegetation is green. See, you have the visible green and the visible red. Why the visible red absorbs? What does the plant make it good? So the visible red part of it happens. That's where the leaf is healthy, the more absorbed it takes. But in near infrared, it reflects more because it's a leaf structure. Internal leaf structure, if it is well spread, so there will be internal reflectors. The internal reflectors more, then you get more reflectors. See here, almost like 40 to 60%. But when you go to shortwave infrared, what happens is there is also reflectance. This is directly related to the moisture content, or in the land, or on the vegetation. The moisture is less, it becomes sensitive. In infrared, you get a bigger one, but in shortwave infrared, it is less. So we can differentiate a healthy leaf. But if the stress is coming, we can pick up images. That's why most of our sensors are also having shortwave infrared. What we do from India, because we need to know the health. How do we know the moisture is less in the leaf? That doesn't happen. No, one is there is no water, but then also there is stress. And second condition, hot weather also okay. Evaporation is taking place, transpiration is taking place. Then, whenever you are not well, what happens for you? Doctor does not drink water, What is happening? We are dehydrated. So the same thing also. The plant also, it is having some diseases. So first thing is the moisture is getting out of the plant. And that makes the stress conditions we can detect that early itself. See, we are all doing the technology. Previously farmers used to go early in the morning before the sunrise. Then they can identify the crops and the paddy, any crop, how it is responding before the sunlight falls. Then after sunlight falls, everything you get in energy. But before that, they can identify how the leaf is drooping and not there. That is their result. So they identify these are the areas which you need to get attended. But today we lost that because we are busy with elsewhere. We are trying to do something else. So the same thing we have to apply using certain tools and techniques. Okay. For example, I am showing you one small example here. See, this is a near infrared and this is a shortwave infrared. Here it shows in red tinge, but this is what is called a cut rock surface. It is very hard rock. After the weathering has taken place, it is all plains, absolutely plains. But cut rock surface means it's more harder than a hill, because it resisted the erosion. If you want to make a pipeline there, you want to make a canal there, it's very difficult. You have to blast the area. Or the residuals have certain contents also, anomalies and minerals. So you can see the water body is coming out very clearly. The floodplain is not clear, the floodplain is also up to here, and this is canal running here. So it's all for geotechnical, any of our inferences, the more you get a different wavelengths, we get additional information, and that we should be in a position to infer. Okay? Next. And this is what in black and white you can see the tree plantations, certain gaps in the plantation. These are all orange orchards. These are all in 1 meter, and you can see the lanes, the roads. And this is, you can see, this is even the trains, work is going on here. So the trains are doing the work. The dam and the train work is going on here. Small patches. Every detail is there. More detail means, but how do you identify each one? Suppose it's a very broad image, this is land. First image I told you, this is India. Correct? Right? And there is a list, guards, western guards. Easy to count. Easy to identify them also. But then when you go to these details, if I ask you how much is agricultural land, where is paddy growing, where is potato growing, you can ask these questions. There's so much of data in which you analyze. That means there's a lot of noise also. Not only the data what you're looking for, but there's other information also embedded which becomes a noise. So, more the better the information what you call, more the signal, you also have noise along with that. So we should know how to minimize this noise or process certain digital processing techniques, how to avoid this noise. There are different filters out there. These are also in some parts of our curriculum. And these are bun, and these are tank, with less water. Okay, next. And you can see this is part of the work taken from all satellites, tall buildings, then you have shadow. Under the shadow you cannot see much, but with the shadow you can measure heights of the buildings. With the inverse you can measure the heights of the buildings. That means one disadvantage but converting into an advantage. Next. This is where the stadium, this is somewhere in Romania. Not only the stadium, you have some strings here. There's a steel wires, cables, and the shadow of the cables also are visible. This is what is called radio resolution. That means even the weakest signal, this is a feature which is giving a very small response. Small response also. We are able to calibrate and catch it. That's where there's another resolution is called radiometric resolution. Okay? So it is not that how powerful is your lens, but whatever the power of the lens is determined by the radiometric, what is capturing electronics wise, the dynamic range what we can give for it to get registered. That is what is called radiometric resolution. So our satellites have very good radiometric resolutions now. And that's where we are able to do. It's part of Romania. So you should understand that means our satellites are not India alone. Whatever we launch, they are all global satellites. So you learn something here, you can do business in US. Why not? Or you can go and do business in Saudi. Anywhere we can do. Right? So if you understand all the environment which I told you the first piece of diversity. If you're trying on all that, Dubai mostly you have what? Sands, right? And certain things of planes where they do artificially, they try to harvest and then there are things we doing similar there. You learn what is there in Rajasthan, same thing you can apply there. But of course, few small conditions you can change. Can we or can we cannot? We can do that? Yes, correct. So that's your strength. Next. It's all in Egypt. This is a pivot actually. It's all green color. It's light appearing here like that. So these all vacant. So how the pivot is doing irrigation and which parts of getting a crop, what stage of the crop, we can tell very clearly. Because the crop also in different stages it needs some amount of water. This is called irrigation scheduling. Scheduling that. Like we have a schedule now. What is our schedule? Morning before going to school. Have breakfast. Correct? Without breakfast, we cannot go to school. Because we feel hungry, then what we are going to hear? We agree or not? So, similarly, plants also, there is a schedule for it, called irrigation schedule. Not for trees. Even for crops like paddy or wheat, we can exactly give at their root that much of water what is needed. So, we can save more water. Because in future, or not future, even today, there are a lot of scarcity of water. But the satellite images are there every day. Every day you get these images on the day. There's a geospatial satellite also getting launched. Unfortunately, one what we launched was not successful. But what is going to get launched will give you data 3 times a day. But we have to make the response curves for all that. But there's a different part. But still, you will have more data to understand how the crops are performing and how much of water they require or how much of fertilizer they do need because of the stress conditions which I mentioned to you. You can exactly get the details and distribute that to different distribution systems. Next. And this is the radar images. Okay, radar images are not like the normal images what we see in the optical image. They'll be different because they'll be penetrating. Suppose if I take an X-ray, you have seen X-ray, no? So it is going to our body and it's giving some forces. If I don't label this belongs to someone, but this is not, this belongs to Varun, for example, and I club it with something else, can you distinguish? Suppose my X-ray and his X-ray, they are not labeled by name. What is the difference? Unless there is a broken hand of mine at a plaster, he doesn't have a broken hand. Okay, then it will be different. But when something is penetrating, for us to understand without what are the view which you are doing, you are not able to do. So we have to make certain markers for it. Each feature, how does it reflect when it is scattering from some surface? Where is scattering is? Where the moisture is coming in, it starts scattering from. Or certain factors of vegetation, different type of vegetation, canopy, the type of growing which is being done. This scattering happens first. So that is what is called we try to detect such features. But we can use along with the optical data. And then where we understand the optical vision, both together we can make the inferences. So this is all weather capabilities. When rain is there, you don't get the rain is there also we can get this information. So both put together. The rain is not coming continuously, no? One day it comes, other day it cannot come. So when we take the opportunity, we can make a measurement and we can have information related to both places. Okay, intelligently using now. But the other advances are very expensive. Complex technology. Even making it an antenna access is very complex. It's a huge satellite. Whatever we have different frequencies. I'm not going to frequencies level now. Okay, I'm going to tell you broadly. Next. Go to the next also. See, this is how it is. This is an image of 3 days. This is August, October, now. In rainfed agriculture, initially in August, because a lot of rains come, there is a lot of soil moisture. The soil moisture is one information which we look from these microwave satellites. If you know the moisture at what level is existing, what type of crop can you sow? All green and blue is more moisture, but it's becoming more pink here. So by November, so is the soil moisture is reducing. So when you go for the next crop, it's called the winter crops. It's also called rabi crop. So it needs certain irrigation. How much irrigation can you do is a different part. So I'm showing basically from rainfed agriculture, which is almost 68% of our agricultural land is rainfed agriculture. So they will look at the monsoon. Whenever the monsoon rains come, that is when what seed should go and what fertilizer has to go. It's a big exercise they can do. That's a very big business altogether. In fact, if you want to become an entrepreneur in that area, you can become an entrepreneur. So they have all the data, tell all the farmers which, based on rainfall, advanced prediction of rainfall, we can tell them which seed has to go where. If so, for that seed, what fertilizer has to go. So these all based on analysis which can be done. Next. These are the, I'm not going to this, how do we understand image? When you see a photograph, we take some photographs. Correct? Group photographs. So when you take a normal photograph also, how do we distinguish each one? Because each one has some complex, because it reflects. Okay? How it reflects. Suppose if I keep so much of white powder on my face, how it reflects. My teeth are white, right? Advertisement will come up, keep coming. Right? Someone smile and that thing will write. So it's a reflection. And also the dress patterns. These all matters a lot in which for us to distinguish the features. So similarly, here, how do we elements of interpretation I just mentioned here. Okay? The basic elements of interpretation. I will see what are the slides which will be useful to you. I'll make the PDF and ask the organizers to share. So that later you just go through, so you get some idea. But if I want to make this machine understand, so I go to signature library, we can make the machine understand and do the mapping part. Which one is agriculture, which one is paddy, which is tapioca, or which is mango orchards. We can make the machine to understand by process. Okay, there's a different thing. So the machine looks at first the color or this gray tone. I go into the reflectance. Suppose you had map, not the shirts, but our faces. So the variations, the gradation in our reflectance includes. Then you have to distinguish our features, then it has to go to the shape, spatial. So it will take the edges, all edges. Okay? In frequency, it is called high frequencies. All the electronics engineers and all engineers here will understand. frequency. In the image, we are talking frequencies, they exist all high frequencies. But what is the other part is low frequencies. In between, the aggregation band is there. So in between, whatever is there, all low frequencies. So it's easy to do the image processing, compressing the data in a much better way. But this is the way it looks at and makes objects. It also takes an priori. Today we call it artificial intelligence. So even if I have to classify this, I can give intelligence to the machine. That in this area, this is the probability. Or there are different algorithms we can feed in. So it knows in a given sequence, in a given area, the probability of something is per particular class. How it can be determined, or it can be, for example, coconut and areca. Both are palms. How to distinguish? There in some place there will be grass and there will be paddy. Those are the same. Whereas for onion, it's very challenging for us. Onion is electrostylus leaf. That means how much is getting reflected is very less. It's leaf in nature. So we have to do neural network. That means how our neurons are functioning. We do train the machine in the neuron level and give information weight we have to process to pick up this onion crop. So the leaf structure is called erectostylus. Erectostylus. It's straight, it's not exposed like this. So we are not able to see from the top. Okay. So these are all the constraints, but we have solutions for it. So we have solutions, but we have to understand which to apply where. That's the reason I am trying to do the variable. Next please. And after doing it from images, we convert that into information. Information can be a point, a building, like where we are right now, or it can be a road in front of us, it's a line, or we are able to get a boundary of this building, it becomes a polygon. So these are how the information is handled. This is what is called as GAs, for you to do the analysis. So this is all we are doing for a very long time in history. You know from when? Can you guess? 1988 onwards. 87 to be very precise. I went to Nagpur and that time machines with 4 MB RAM. What is RAM in your mobiles? I don't know what is there in your mobile. More than 8 MB. Most of your luxurious guys, they all have 8 MB RAM. 4 MB RAM and 456 MB disk space was occupying almost this platform. Okay. So then the load is changed. Your mobile, you are able to do all the things. So we should know even the mobile how efficiently we use. Not for watching movies and things like that. We can do a lot of processing on the immediately. That's possible. Okay? Next. So these are India has given a very innovative way of imaging because we know certain applicable for your AI artificial. Because whatever I see in detail, I don't want to do it every time. So we can cover this entire cover state, and this looks at a small part of district, and this looks at the villages and detail. But all three are imaging at the same time. So the radiometry doesn't change. So the algorithms will be the same. This concept no one understood in the world. And in 1995, India launched such a satellite, and they have given the best resolution for the world for civilian use. In 1995, nowhere in the world they are giving for civil in use better than 10 meters. So what did India give? 5.6 meter resolution. So India is the one who started to raise in 1995. It's not the other countries per se. So but we are at the global satellite, and US was working using our data for their aggregation and other applications. Do you know that? The new information, right? So coming to this network, what are the US Space Lab and University of Connecticut has made an opportunity for us to understand that we are always the best. But we never told too much of what we are best for. Okay? So we have to keep telling. That's what I was telling you, right? Networking, nurturing, negotiating. And these are both stereo images. Same satellite, we have two cameras. The parallax is there. We can get the stereo image. For example, if I take your mobile, and if I take a photograph of both of the glass from two different views, I take a photograph here, I go there and stand and give a overlap of 60% overlap, I take a photograph, what happens? I can get a stereo depth. What like you, just 3 months. There are a lot of collinearity equations which has to be solved, coded, made on that. So software configure. You can download from IAR's website, take some photographs, generate 3D, different upon the commercial softwares. You have to do everything by your own. You have the capabilities within your reach. You don't have to go anywhere. Within your institute, you can do that. Okay? Agreed? Okay, now I have to go a little faster. Next. So when I tell these are images, advanced films covers almost a state in one shot. District in one shot, more than 10,000 square kilometers. And here you can see city or things like close. But you can't see the difference between these two. What are the features which are there here are also here. But this is 56 meters spatial resolution. This is 23 meter resolution. So when you are buying mobile now, you always see what is the resolution. Right? On that. See, even what's the resolution? If I use some high pass filter, I can get this image. Because all the details are there. Whoever processes this and make business, you are the best entrepreneur. If you are doing this, using this or this, there are only many people and you have a combination. Please understand. Today we have so many algorithms and tools which we can simply enhance this data. Once it's present, how to bring it is your challenge for all your electronics or engineering, physics students, whoever it is. Even others also can do that. Next. And then this is the digital elevation model. As I told you, the CEO. The next you can image is not clear from this. Next. So, there is a quarry side in Bangalore. When you go to the Bangalore airport, there is a quarry on the left hand side from the city where you go. How much of volume of quarry has been excavated? We are able to measure in terms of volume. If I know the volume, I know how much of truckloads are. How much of truckloads means what is the royalty to be paid as a to the government. So everything you can measure. So please understand, now we have these volumes of data. Now people are going, National Investigation Agency goes back in time and looks at someone gets a rebate or capital gains, whether they are eligible or not, they find, and today they are penalizing them. Not only the penalty of tax, but it's also criminal case. They can be both taken to jail. This process, and it's a true stories. It's not a, even no one can escape from it because all the data is there right from 1972 onwards. So foreign satellites in India from 1988 onwards, and the photosat and other things came subsequently. Then we can also find the heights of the buildings, excavation, what all happening. This is a minus and this is a plus. Everything you can get, and we can go contours also. It means for all of things. This is a global satellite, and it has contributed for all the Asia Pacific countries. Every continent today we have the data on their digital elevation model from our water satellite. The satellite's life was 3 years. We worked more than 10 years successfully. And we could do a flexible operation suite because the hilly areas I told you they will be shadowed. So we do the reverse of it. Instead of descending, we can do a different way of programming the cameras in a tilted way. So we can get the other view of also the game. So we can so this is where your innovation comes to. It's not a tool what you handle. How do you handle this tool effectively for the purpose which is supposed to do? And if you have a problem, how do we do it analysis? Okay, everywhere there is an opportunity for you. But here you have to have the will to understand and well understand. You don't have to be a wrangler to be that. You don't have to be the first wrangler. But first, the attitude should be there. I have to understand it. Okay, so that till we understand better, we cannot get the next one. So we had another series of samples. See, I told you from here I take a photograph and you get a see. But here something else has happened. We had photosat series, we kept an EVM on camera. This EVM, what it does is, whenever you look at a location, the earth is moving, right? Satellite is also moving. But this camera is looking at the same spot. When two things are moving and you are looking at the same, it's like taking photographs of two sides, right? The same principle of parallax, we are able to generate this precision. On the news was there, no? We did a precision bombing as a targets, right? It's all done with this. So we know its location very accurately. We because it's seeing at the same time, same location for long, and we are able to get the 3D heights. This is Raipur, and you can get a profile of the river, pond of profile, everything can make it. So we have many samples of this nature today helping in getting a lot of intelligent data, what is needed for our purposes. Please understand, sustainable development doesn't mean only using the resources, but someone has to allow us to live peacefully, right? If there is no peace, how will it be sustainable? We agree or you don't agree? So we are the subject only, right? Did I deviate from the subject? Oh, next one. So this is where this little understanding is good. How does the water flow? How does the water flow in the system, in the natural system? Huh? Higher to lower level. So that's what is called streams. Streams become rivers. Okay. But there's a secret, another secret, great secret. Okay? God has thought about these people, human beings will dam all the rivers. If you dam the rivers, what happens? The nutrients will not go into the sea. The nutrients doesn't go into the sea, how the fish will survive. They also get nutrients from the land. There are a lot of nutrients, it's called biogeochemical. Nutrients has to go into the ocean. But we instead with all the dams. So what God has done is, I don't know if God exists, but I'm still using the word. He made the hard rock when it moves because it breaks. Okay, it breaks. When it breaks, like when you have a fracture, see it is vulnerable to erosion, those places. That means weathering will take place fast. If weathering takes place fast, the moisture accumulation will be there. If the moisture accumulation is there, the stage grows more thicker than the adjoining layers. That's how you enter. So they are linear, they are heavy linear. So in hard rocks you get water, identifying these fractures and joints and their intersections. You do not go on the same ridge line. It can cut across ridge lines. It can go tangentially. Okay? So the tangentially, what also can move. Do you agree? So for this entire country has to be mapped. Where to conserve resources, conserve the water charge, how to recharge, and how we get the water, how much of water we can get. Everything is mapped and is available to us in terms of different maps. Or if we say success of the wells, very hard work terrain is all possible. So this is where my friend, Central Water Resource Department, they need here in Calicut. Please here. Next. Yeah. So but then that is showing from a distance. But if you go closer, you always think if I go closer, you'll get a very good view. But also there is a confusion. See here, the same fractures got diffused. This is a fractured one. There is agriculture going on, they widen this. And this is a dike. Actually, this dark one, actually dike is an obstruction. You may get water here, other side will not get water. Because these are all dikes. So this is all we can do from images and info. The next one. So these are all the applications, either for smart cities or Amrut towns of planning. These are all village level planning. In fact, Kerala is one where we have the panchayat level decentralized planning which takes place. So this is where all the information to that level of planning or the hot weather outlook or for climate change, when you have to tell, there should be authenticated information. There are something like 51 essential climate variables. And out of that, 25 are immutable with space inputs. Others have to be done by the field. We are doing now 30 and we are publishing. And these has to be validated, globally accepted. And it's available on the website called Bowen, where you can download this data, what has been processed and kept for any of your research. So unless this is there, we cannot exactly measure, quantify the what the amount of climate change which happens. Okay? The next. And these all in agriculture, fisheries, potential fishing zones, where the fisherman has to go for fish catch. Everything we have ocean sand satellite. Picture the ocean color, sea surface temperature, and also scantlometer, which is not imaging but also gives the information of the wind. So these three parameters are important. We have launched now Ocean Sand 3, and this is a global satellite. If you learn here in the West Coast how to tell the fisherman where to go, you can also go and tell in California Bay where the people can go and do fishing. Can you? You can go now because we are learning here. The same course. It small tweaking of the local ecosystem, that's all. But same algorithms will work. Or you can go to Japan and do business better than what they do. Because I told you, diversity what we have is huge. Whatever test is diversity, where there is a homogeneity in other places. Here we have more heterogeneity, there it is more homogeneity, less heterogeneity. So it becomes easier for us to do business there. But we are not thinking. We are all thinking the others are great, but you are much greater than them. Please understand this. Next. So I didn't go into all the resources and other things per se, because that will get to the website will go. And this is how we can monitor. What the next slides are basically on monitoring the irrigation command areas. Means how it is started in it and take temporal coverage. Means I take data today, after 10 days, after 15 days, and how the irrigation is going and how the crops are responding. What stage of growth has come. We can measure such things. Those are the type of slides which are there. Which you can also simulate and see. Means it's an animation. The animation also will show you how the irrigation is happening and how the systems are performing very precisely. If you do all that, what is the opportunity you have when we talk about such management resources? You can do also mineral processing, where diamonds are, where gold is, or what are the source and how they are moved. Because most of the time the source you get to one location, where the rivers and all will erode it and take you to another location. So these are called transient deposits. If the source is one location, which has an association of group of certain rock types, and an anomaly which creates that. For example, simple thing is diamonds. So we look for where the volcanic activity has happened, where the cooling has happened very slowly, and there is a possibility for getting diamonds. So there will be a small elevation, small bomb. How will it take from images? No drainage will be moving along that. They'll make a circular drainage. When you find a circular drainage, you know these are opportunities where you have in the rock bearing things a certain type of diamonds. But then the stream comes, it keeps eroding, right? When it erodes, stream takes some diamonds along with it, right? But it has the ability to take it further. So one is the active streams. But when you have the failure channels, because this after the stream moves, most of the rivers, big river systems are not there. They moved actually to another location. So we have to look at where the failure channels are there, where also you get abundant resources. Got it? This is not the source. You can go elsewhere, different ways that you can go. Yeah, this is the simulation which I told you. Okay, just to excite you how we can monitor the command, how much feed, what we use. So these were demand-based relationship. That means how much exactly I have to feed that water. Still here it's not totally demand supply, whatever. It's still supply, but we know to control. But we can control today to a larger extent, and government has schemes to make instrumentation. If you have to pump this water to some other location. But one of the seniors who are there here, from Space Club, can ask me questions later, how to make business out of it, how to make sensors, what is the type of sensors we have to do, not only for space, for interviews where we can create up. See this fellow, that's what I was saying in the morning, when I learn something from insects. You all heard last year there are a lot of problems with locusts, right? Yeah. The locusts just keeps a day 5 to 7 centimeters. And it can detect everything. It can tell soil texture, soil moisture, and also looks at the facts of what is the vegetation, including salinity. And we don't have that kind of instrumentation, such small in nature. So we have to learn. But with space information, we are able to get this data from different sources and analyze. And given advanced information, when it reads and when it becomes open and alert, then you can accordingly say. But this happens in some places in Egypt, and then there's keep moving and go up to some deltas or western part of the country. So we need to network in other countries. Give them the advanced information, what procedures that follow before it becomes alert. And these are the life cycle. From egg to how much stage it happens. So we identify the potential size, field level, peak class will monitor. The monitoring system, we are doing in our country. But other countries doesn't do also the problem can come. They're seeing the pandemic, right? Problem is not here, problem is somewhere else, and they also solve this. But we can do early prediction of all this. This is we implemented for healthcare now. Yeah. Yes. Excellent. Okay, we see this. This is online nuclear emergency response system. Because nuclear radiation when it comes, can you see? The heating will just fall, right? Or we get some, based on the exposure, we get certain nuclear effects. So, next one you get. So, these are all the parameters we need for Kalpaka, the indigenous software. So, we know the leak of the radiation, how it will move in the next 72 hours. So, you get 72 hours advance notice. And it is available on mobiles and apps, NGOs, or where to go, where the ID goes is kept, and everything. The law also is 10 years old. They are not 12 years old. They are business things. But we need to do more. The people are asking something, some nuclear attack happens in 100 days. Can we detect what is the range of impact? We need to do that. We cannot do it. Okay? This is where we have the weather information. We need to do that. Next. See, basic question came for you are wrong, chairman. So, we are seeing an image. You are talking about water, you are talking about station, you are talking about soil, everything you are talking. That means they are not connected to one another. Did you ever see how they are dependent on one another? Can we tell the potential of it? To do that, we need an experiment which is controlled. This controlled is watershed, because in nature you have a drainage divide. From there all the water will come down and collect in one spot. So there are catchments, subcatchments and watersheds. But here we know how much discharge is coming, how much is inner solar radiation, and how much is going out as a runoff, how much is potential of transpiration, is all we can measure. So in between the human being will come and start using something. If they are converting some land into agriculture or some land into buildings, everything will have an impact. Building means more runoff will start coming, but there is no calculation. So there is no impedance. If it go faster, runoff will happen faster. Next one. So this is where the concept in which we work, and then for we started putting on land and water resources development. Where to put check dams, where to put beds, but all quantitatively, not qualitatively. We could do quantitatively with certain algorithms developed, but people's participation. Finally, people's participation is to accept. Then the next one. This is how you get the detail. Each village wise where to do what. So this is all available now for entire country. It has been done. But now the people have to use it. So you can ask the question, where is it? How to do? How to proceed? Or how to do for sustainable development. Next. Change. Agro-horticulture, horticulture. Next. And a great question, when we give all this information, they are planning, they are using it. But one intelligent ideas of the ask, space will be space. We know what to do in the future. Good question now. Because everything is good, people are using, they are spending money. But when someone makes a statement of that nature, we start questioning what did we miss? See, we should take it always in a positive sense. Not in reading, I made a very good map, everybody is accepting, they are spending money, also they implement, why this question has come? Then we understood that all the government schemes are beneficially oriented. Please understand this. Even when our education process, socially, academically, because we have to support. Here also, the small farmers, marginal farmers get more subsidies and benefits. That is a scheme. So that means whoever is taking the scheme, if the land has certain potential, they have to also identify who owns this land. That information is not in this room. So that information is maps, and that maps doesn't have projection, that means there is no geographic coordinates. So then we have to innovate out there. To find out how to get geographic coordinates by getting the control points which are there on the image and also in the survey boundaries, like tag boundaries like this. We give certain control points and we need transformation. How many of you studied polynomial transforms? Yes. study polynomial, no? You don't have to solve the equation. You have to study, no? First order polynomial, second order polynomial, third order. Yes or no? Yes. So we use the same here, same polynomial equation rule. But we did it such a way acceptable for people. The land should not be lost, but it should bring the shape of the earth also. So what map doesn't have the shape of the earth. So this entire transform. So this color is one village, this another village, another village. So entire country today, everyone comes and shows your map, telling that here is a road, here is a building, new building coming, this is a government property coming, real estate works itself. That's all possible because this has been done. Because we related the maps and the satellites together with geographic coordinates. So you can transfer all the data vice versa. So this is done in 95 and it can be entire team is reviewed in a bigger way. Next one. Yeah, this is where you can see this river was here. The village is located here. You can see the shape? It's like a river, meandering, right? But the river has moved. But tell that here there is a sandy texture. And then it moves. So if you get anything here or here, you have to see between also you get diamonds or gold. Okay? Just for an example I am showing. Okay? Next. This is all. You see the difference here in this photograph. What is the difference in these two photographs here and these four photographs? We are connecting a village fields. What is the difference between the first two on the top and the bottom four? Huh? Huh? Yes, you're right, absolutely right. Why day and night days? The daytime everyone has to work, right? Let's be. This is the night. You finish their dinner, they are happy storytelling time, because there is no TV at the time, entire village is there. So you want to explain something which is good for them, you get a good audience. Well, so you have the timing. It's not that when you get an idea, only you go and speak. You have to time and tell them there should be an audience. There should be people there, they finish their dinner, the police. Then it doesn't move to here. Okay, this is where please understand. It's not that when you get an idea, it is hard. Timing. Timing is very important in life. Next. Anyway, these I will not conclude. We go to the next one. See, the reason is humans know, for example, these are different slope categories. They know how to make the shape of their buds very clearly. Because they know how the moisture has to move. This is all the vocal wisdom. Please understand the vocal wisdom. In the morning, speaker also was telling vocal wisdom. They have sustained for centuries. They know how to survive. They survived and gave the battle, so we are enjoying the fruits of it. Do you agree or not? Yes. So that's the local wisdom which is existing. So while doing technically any plant, we have to go to the field and understand the local wisdom. Anyway, this is more details with the numbers and all the points. So with this, but then humans what they do, here, one is sufficient, but he makes three. This is wrong. Even at such a smaller level of 4 or 5 acres of land, if you do any excess, capillary action will take the salts in the adjoining areas, and then you will have salt effective. So when the salts are more, osmosis doesn't take place, so agriculture will not become any. Simple. Very simple logic, right? So we cannot do more. So we have to understand what is sufficient. Everything will compute. But people, once they get results, it's a small thing, then they start working on more. That means we have to monitor. Other two I will not explain. Okay. Next. There are other examples, case studies only for you to better understand. Yes. So these are all now many projects because Prime Minister wanted all the ministries to do. There are 86 ministries in the country. He brought them everything on September 2015. We had a major conference on one day. And every secretary has presented how they use space technology in their departments. It can be skill development, it can be justice, everything has been made. Next. And these are all the very simple examples which are there. That is not well there. Yeah. Including the third livelihood option. What's the livelihood option for agriculture is agriculture. But if it fails, we give permanent tree tops. That's called horticulture. That's why you're getting fruits. Pandemic time also you got all fruits, right? The same cost. Why did it happen? Because all government has identified the potential sites for horticulture. But the third level of option, what we found in many of the districts where I told you where more than 750 mm rainfall, there are a lot of ponds. And if you maintain them, there's almost like 5,000 tons per year of fish you can get. You're all about sea fish. Sea fish is all different fish, freshwater fish. And there's a lot of market, within the country and outside the country. So this is the third livelihood option which has been given for all the country, and then people are giving benefits. Government is giving benefits. This is precision agriculture which we do. So this is where ISRO provides all the private industry for understanding the satellite-based, field-based positioning is also important, navigation, and how to communicate whatever you process. Not only knowledge I kept here, because that's what we gain, we need to get the result from the local knowledge resources. So we go for wide and so on. But we want to become smart. We want a smartphone, smart agriculture, smart water supply, right? They all get it now. Are we don't want to become smart? Go on, right? Yeah, the world is going towards that. Next. So we need now a lot of sensors. This is what morning I was telling you. It is very easy to think. It is very good to think. Don't read the books and the publications. If you think independently, you can do a lot of innovation and cost-effective mechanism. You can do in every part of our life. When you're walking, talking, everything you can do. Next. But we need to process all this data. That's a good opportunity for each one of you. Next. And these are the Sustainable Development Goals 17. Each one you read looks different, but space has a component, either in terms of navigation, communication, or Earth observation, as part of every Sustainable Development Goals which the UN has announced. That's why we have to understand not only we do, but also we should match with what globally we are talking about. Next. This is what ISRO's future plan in terms of security, disaster risk reduction, the social security, sustainable development. And for this we make the satellites and we have the launch vehicles first. So all the entire ISRO programs are trying towards it. The next one is space science. Next. Okay, this is governance. Surprisingly, the governance also uses this sustainable use of natural resources. So in entire part of our system, or three-tier administration, what we call federal government, state government, and the village level, everything is imbibed into our governments. So there is nothing which stops us in terms of people's participation. Next. These are the satellites which are going to come. Next. We are not local, we are global. That's what I want to tell you. This is ocean color monitor looks at entire globe. Next. Anyway, this morning I expect I will not go to space sciences. The RG are going to see shortly. Yes. But then please understand, we always have our goal, how to reach them, how equity. Our goal is not get excited on things. While getting excited, our thoughts and ideas, how it will help the poorest of the poor get 3 meals a day, and slowly they also come out in life by learning, etc. That's what Real Space Club is doing. Bringing all people together, getting them an opportunity to understand and learn from the experts, either in person or in a hybrid gathering. So, but then we are still sufficient for our need, but not for our breed. Even I tell today, people ask me a lot of questions, selected people, represent MLAs and all. Sir, I said, something is happening like that. Do we have something to do? If you even wake up now, we have sufficient for our 1.4 billion population. If you don't wake up, you are gone. We cannot run anywhere. Because we have three sides ocean. Other sides you have hills. And no friends on the other side. So where will you run? We have to survive here. We have to sustain. And we have to become one of the best communities where people have to look at exams, class. And think once again. See, this what you are seeing here, this 3D is taken from a mobile. So please understand, always it's not that in space where you are with you. You have so many devices in your hands. And you can try it out innovatively to prove your point using such devices because it has an observation, it has navigation, it has a communication, and it also can store data. And it is also doing 3D. See that? That thing is done by the mobile app. What has been. So everything is with you. Now you only have to think and come out with certain good applications which are good for humans. and benefit of the humanity at large. Let us not get localized and big. Once again, thank you for this opportunity, sir. Sorry I took maybe a little more time. The topic is a tough topic for science and uni, okay? But still I try to adjust between each one of you to bring in some concepts. So technique you are learning, but how to learn, apply your learning is what is more important. And all the best. The future is in your hands because looking at you only we feel happy. Our future is still good for the country and the people. All the best. Thank you.
Thank you, sir. Now we have a wrapping session. Krishna Murthy, sir. You have any questions you can ask now? Please raise your hands.
I know, but I'm not an expert in that. Okay, but still you ask the question. Yeah, I have a lot of work first. Okay, now I'll ask this question to my employees. Now that's a good question. Yeah. Not magnetic. See, there is what is called superconducting quantum detectors. So, for example, I have a submarine. Okay, so I'll tell you a simple example. There is a submarine, a small body in the ocean. I can detect it. Okay, but it has certain properties. So it is made with some metal. But then bottom also the earth is also has a lot of metals. So to detect this small object, the background of the metals will be okay. So what we do, it goes on. But if it goes on, what I do, that who is there in that submarine will know that someone is trying to trace him. So without his knowledge, track that, there is this superconducting quantum detectors called SPITs. And the SPITs has been kept in a pattern image. Even from a helicopter, you fly and we can identify these objects. But it's tough. See, what? It's touching mechanism. I showed you also what the sound is doing. So humans think they are very intelligent, but they have to learn a lot from this. Okay? So this is called superconducting quantum detectors. Okay? And these are the future. It's not it? Different than what we normally use. But it may be using combination of things. You don't know. Right? First we should understand what the combination of it is using. That's one. That's why in the morning I told you we have learned many things from life. Like it can be animals, it can be insects, it can be butterflies. Okay? It can be anything. Once we observe that, then we all only will look at because we have a limited understanding. We only will look at its use of magnetic. Beyond magnetic also we use multiple. see, human being also, we're not using only eyes now. We are seeing, we are hearing, we are having fingers, and we are seeing association of things. In which environment we are looking at everything. Simultaneously. Similarly, these answers or panels, they look from different perspectives. That we should first understand. And secondly, how to bring instrumentation, which we do not know. But the instrumentation to make it miniaturized, that's the challenge is. Today we should do all. Right? If the dogs, there are great dogs, if someone is getting that epilepsy, the individual will not know. But the dog can detect 15 minutes before. Right? That's not, yes. Not the red fox. So what passing the red fox because they didn't use predator. Yeah, that I cannot answer you. Because that's a different subject. That's why we are dealing with Arya. Okay? No, I understand your questions. Okay? But I'm happy that at your level you are asking so questions very clear, crystal clear. In fact, morning I was discussing with our senior colleagues. But please understand, the world will not be so smooth. So you have to understand whatever the ideas, until then, negotiate. Okay? Someone doesn't ask a question. The first question I come back to you. Whether we can generate energy to give space or volume or this. But the other part I try to answer is, even we don't fully understand, we know only major mechanisms. There are many minor things also and interplay between them. And you are right that we should learn from that and make our instrumentation, but we are making it more instruments. See, for any instrument we use, it generates some thermal emission. We need to control. We need more processing, more control. But the animal controls it. We have to understand how they control. That's what we learn now. We have to be ready. Taking. But it's not that we can, but also you have to maintain an instrument. It's your environment. Space, when we keep these cameras and all, there's a lot of thermal emissions keep coming. So we keep cooling it. So they perform. It doesn't get saturated. Anyway, you just hear, that's all. Later on we will discuss. Okay? So, if you make an instrument of it, it's possible. Everything is possible. But you have to collectively think and come together and do it. Okay? Good. Okay, good. Want to lead, keep it up.
And lot of questions are coming. This boy is asking on the line. I just want to say this Adil is here. It is a side problem. It's not a review. Just see, if you want to do something, you must express and make it happen. So he made it happen, make it late. So this is a session which you are unlikely to get from Space Club unless we will remember or people like or these Shishas. So if you have anything to ask, don't worry about time. If you have any doubt to ask, what is the integrated mission for sustainable development? I think we should ask the question. Whatever you want to know. So since
Good afternoon, sir. My name is Sankari. My question is that if India was fighting in a hypothetical war with some country in a war, would we use submarines and other ships?
Yeah. See, one is ship tracking. We have AIS now. AIS is the system. Once we know there are, actually the new policy of industry coming in, they are making a very interesting standard. He has 3 payloads. Okay. One is either on the land or on this thing. He works on a frequency called E-band. Okay, you remember that. In that, any anomalies on land or water, once it picks up, the land will be different. On the ocean, you will use the AIS. AIS actually tracks any object which is moving, but is on the surface of the water, not surface. And on the land, he uses the coarser resolution satellite, but with the algorithms he improve, processing on the satellite itself to give real-time data. That means any of the defense when you ask, I need real time. That means happening, you have to have the information on your either mobile or whichever device you want. So that is innovatively doing a small satellite for this type of applications. But subsurface submarines which I mentioned to you, only today taking these sonars. Okay, they goes on. So we send, but then we will try to know, the object will try to know if there is a submarine, someone is to track. So then they will go out of the place. So you cannot target it, right? So this is where the superconducting quantum detectors, which can convert into speeds, and the pattern you to put the speeds for imaging this, you will get the information on subsurface. That's the future. We don't have, we are making it now. Yeah.
You can use any language, Malayalam, Hindi, English, any language.
From Melbourne.
Speak in Malayalam.
നമ്മുടെ വെള്ളം കളർലെസ് ആണെന്ന് പറയുന്നത്. വാട്ടർ.
Yes, yes, I understood. Well, water.
പക്ഷെ അത് സ്പേസിൽ കാണുമ്പോൾ ഭൂമി നീല നിറത്തിലാണല്ലോ. സ്പേസിൽ കാണുമ്പോൾ ഭൂമി നീല നിറത്തിലാണ്. പക്ഷെ വെള്ളം കളർലെസ് ആണ്. എങ്ങനെയാണ് ഇതിന് ബ്ലൂ പ്ലാന്റ് എന്ന് വരുന്നത്?
Yes, because of it. What is the rarely scattering activity? We have different scattering now, scattering of light. So there is a light actually the rarely scattering tells when the particle size see the incoming. Yeah, shall I ask you a question? What your question is? When we see the water is dark, but when it speaks from the space, why the blue planet is blue? Correct? So this is all scattering. The atmosphere, because of the particles which are there, and depending upon the frequency which we are trying to use that. If it is a different frequency, I can get a different color of the earth. But the normal frequencies which we use in visible blue green, this is a filter what I am using in normal water. You get this kind of color because of the Rayleigh scattering. Okay? But then that is the principle which we use to identify, even through the scattering also we are able to identify the fish in the sea. Correct? From 400 and 500 kilometers. So we eliminate what is the noise and try to find a signal that is called water leaving radius. So we don't like what Abhi has asked me. Adil asked me a question. So I told multiple things we have to see. So it's not only color, we look also at the sea surface temperature. Means conducive temperature where fish can be comfortable. We're all here very comfortable now, but the temperature is controlled. Suppose in the outside we are talking, can we be so comfortable? So fish also needs a comfort zone for its food to form and food to be available. So these two parameters we identify for the potential fish zones. But the potential fish zone, the water currents are there. The currents are key. So I don't know, today it is here, tomorrow it is going to sell somewhere. So that's why we use wind vectors. As a scatterometer gives the wind vectors on the ocean. So we know how these currents are going to move. Along with it, the food particles also keep moving.
Planets ഒക്കെ ഓർബിറ്റിലാണല്ലോ കറങ്ങുന്നത്. പക്ഷെ ആ ഓർബിറ്റിൽ അത് പോകുന്നില്ല. അത് വേറെ സ്ഥിരത്തിലൂടെ കറങ്ങുന്നില്ല. എന്തെങ്കിലും ഫോഴ്സ് ഉണ്ടായാലും അത് സംഭവിക്കും. എന്തെങ്കിലും ഫോഴ്സ് ആണ് അതുകൊണ്ടാണ് അങ്ങനെ
Or Saturn, or Earth. I'm not certain. Okay, you have much better. I can answer that. See, it also is moving, but it is also moving along this axis, right? In fact, there is a drift, which is very minute. Huh? Right? See, for example, is the light bending? Does the light bend? Not, but we are told light doesn't bend unless it gets to water, correct?
Right.
So the light what is moving, bending, but we are unable to see the bend. We are not able to recognize. Okay? Yeah. So what I feel, there is always, whatever is orbiting, there is a minute drift which happens which are measured, and it comes to it because it is going on its axis and then rotating. So each one has its own track based on its density actually. So when these two properties are happening, you can get one particular field.